Hi, this is CCNA Security. Packet tracer configure Cisco router for Syslog, NTP, and SSH operations. So the network topology shows three router. You'll configure network time protocol, Syslog on all routers. You'll configure SSH on R3. Um, um, you configure SSH on R3. This is the R3. Network time protocols. Network time protocols allows a router on the network to synchronize their time setting with an NTP server, a group of NTP client that obtain time and date information from a single source, have more consistent time setting, and syslog messages generated can be analyzed more easily. This can help with troubleshooting issue with network problems and attacks. When network time protocol is implemented in the network, it can be set up to synchronize to a private master clock or to a publicly available network time protocol server on the internet. The network time protocol serves is the master network time protocol server in this lab. Um, you will configure the router to allow the software clock to be synchronized by network time protocol to the time server. Um, Now, if you look at this pictures, you can see you have a Syslog server and you have a Cisco router and then the switches. Um, Cisco router we can configure to forward log messages to this external Syslog server. This service it can reside on any number of servers or workstation, and this include Microsoft workstations and Unix-based system. This syslog is the most popular message logging facility because it provides long-term storage capabilities and in a central locations for all router messages. So you can send this syslog the syslog messages may be sent across the network to an external syslog server, and you can retrieve these messages without need of accessing the actual device. These log messages and outputs stored in the external server can be pulled into various reports for easier reading. And you can also configure the router console. This is called console login, and it is by default. Um, Messages log to the console, and it can be viewed when modifying or testing the router using terminal emulator software such as Teratram or PuTTY while connected to console port of the router. Um, Now, syslog messages may be sent to an internal buffer. Now, the message sent to the internal buffer are only viewable through command line of the device, and you cannot use the server for that. Login buffer is useful security tools because log messages are stored in router memory for a time. However, um, uh, events are cleared whenever the router is rebooted. And now, so you can Cisco router. You can configure the Cisco router um, for the syslog messages, and this log information regarding these log informations are regarding the configuration changes, access controls violations, interface status, and many other type of events. A Cisco router can send log message to several different facilities. So this syslog implementations always has two types of systems. One is called Syslog server, other one is Syslog client. Um, Now Syslog server, also known as log host, and this system accept and process log messages from the Syslog client. And Syslog client is a router or other type of equipment that generate and forward log messages to the Syslog server. The Syslog protocols allows logging messages to be sent from Syslog client to the Syslog server. And the biggest issue is enormity of the task of evaluating the information. And this information includes shifting through the various logs and events, correlating the events from several different network devices and application servers, and also determining the type of action to take based on a vulnerability assessment of the incidents. Now, our first step is going to be configuring router as an NTP clients. So, which is NTP stands for Network Time Protocol. So, it's very important to understand what is the Network Time Protocol. Now, what is a Network Time Protocol? Many things involved in the security of a network, such as security logs, depends on accurate date and timestamps. When dealing with an attack, every second counts, every second matters, because it is important to identify the sequence or the order of a specific attack that has occurred, to ensure the log messages are accurately timestamped. Clocks on the host and network device must be synchronized and maintained. Um, Typically, the date and time setting of the router cannot be set using one or two methods. Can be set using one or two methods. One is like you can manually edit the date and time. The second one is configuring the network time protocols. You can see in these pictures, this is an examples of manually setting the clock. Although this manual method works in a small network environment, as network grows bigger, it becomes difficult to ensure that all infrastructure devices operating with synchronized time. Even in a smaller network environments, the manual method is not ideal. Um, if a router reboots, how would it get an accurate date and timestamps? So a better solution is to configure network time protocol on the network. Uh, the network time protocol allows a router on the network to synchronize their time setting with a network time protocol server. Now, a group of uh, NTP clients that obtain time and date information from a single source have more consistent time setting. When network time protocol is implemented in the network, it can be set up to synchronize to a private master clock, or it can synchronize to a publicly available network server on the internet. This picture is showing that you can manually set in the time in Cisco Configuration Professionals. You're setting it in manually. This network time protocol uses UDP port 123, and it is also documented in RFC 1305. Um, Now, configure router as an NTP client. First, we need to test the connectivity. Ping from PCC to R3. So we're going to be pinging from PCC to R3. This is the IP address, so the fast Ethernet 0/1 for the R3. So go PCC, desktop, command prompt, ping, and we can see that the ping is successful. The now next step is from ping from R2 to R3. So we're going to be pinging from, this is the R2 to R3. So see if there is a connectivity here. So CLI enable. So what is the password? Password is enable password is Cisco NPA 55. So now we are privileged executive mode. Now we're going to be pinging from R2 to R1. So this is going to be the serial interface. This is where we're going to be pinging. So what is the serial interface of from R2 to R3? This is the R3, this is R2. Serial interface of R3. So this is the serial interface of R3. And see, we can see that the success rate is 100%. The next step is telnet from PCC to R3, and then after that, exit the telnet session. So PC3 telnet to R3. Fast Ethernet interface of R3. This one. Now we have to VTUI line password. It is the VTUI line password. It's a Cisco VDY PA55. And now we exit the telnet session. Now we telnet from R2 to R3 and then exit the telnet session. So this is the from R2 to R3 we're going to be telnetting the serial interface of R3. This is the interface that we're going to be using. ping 10.2.2.1 2.2.1. You see that the ping is 100% successful. And now step 2, which is configure R2, R1, R2, and R3 as an NTP client, and then verify client configuration using the show NTP status. So first, configure R1, R2, and R3 as an NTP client. We go to the R1, CLI, enable Cisco ENPA 50. Okay. Cisco ENPA 55. Now we type NTP and then we put a question mark. We type show NTP, show NTP, and we put a question mark. So we can see that there are two options here, either associations, and we can also check the status. So we type status, question mark, carriage return, and now we can see that clock is unsynchronized, stratum 16, no reference clock. So reference time, it also mentioned the reference time, clock offset 0 millisecond, root delay 0. So basically it is saying that the NTP client has not been set up yet. So this is going to be our NTP server. So we go to the global configuration mode, config T. So we type NTP and then question mark. You see the server trusted key, and so we type server and then question mark. And then you're asking for server ID. This is our server ID, 192.168.1.5. 192 server IP address 192.168.1.5, and then next question mark. Then it's asking for key, which is peer key, to peer authentication key. So we're not going to be the key, have any key at this point, so we just hit the enter. And now what we do is NTP, we type NTP, and then it's going to ask us, give us a number of choices. So one of the choices that we're going to be using is update calendar. So we type update calendar. So the carriage return. So now we have manually updated the calendar. And now we go to the privilege mode, and we do a show NTP status. And now we see that the clock is synchronized. Previously, when before configuration, we type show NTP status, we didn't see any of these messages, which is references server ID, and then clock is synchronized. But now, after the configuration, after the updating the calendar, we can see that we can see the times and date plus the reference, which is server IP address, Syslog server. Now if we go to the server, then we go to the config here, and physical config service. We go to the service here, and we type here NTP, you can see NTP zone, and it's giving us, this is the um, date and time that we have currently. Now here, if we turn the syslog, we can see the syslog on. If there are any messages, this message is going to be generating here. It's going to be generated here, and we can view it from here. Now, when determining whether to use a private clock synchronization or a public clock synchronization, it is necessary to weigh the risk and benefits of both of them. If a private master clock is implemented, it could be synchronized to coordinated universal time, or UTC, via satellites or radio. The administrator must ensure that the time source is valid and from a secure site, or else he is going to be introducing some vulnerability. The, the communication between machine that runs NTP are usually statistically configured. So this communication is also known as associations. So each device is given the IP address of network time protocol masters. Accurate timekeeping is possibly by exchanging network time protocol messages between each pair of machine and association. Now, a network that is configured with network time protocol, one or more routers are designated as a master clock keepers. It's also known as NTP masters. You can see that you use NTP master command in the global configuration mode, and to configure as a master. Now this command makes the system as a authoritative network time protocol server. And you'll see when you type show NTP status, you will see a number called stratum. This stratum number, is the number of hops away from that authority source, such as an atomic clock. You can see here this is the command that we use to configure the NTP server. We type NTP server and then IP address, and then um, we didn't use any key. We didn't need to use any key. All we have used is IP address. Now, if you are in the local area network environment or LAN environment, network time protocol can be configured to use IP broadcast messages instead of using and you use command called NTP broadcast client in the interface configuration mode. This alternative, what it does is it reduces configuration complexity, and because each machine can be configured to send or receive broadcast messages, the accuracy of timekeeping is marginally reduced because the information flow is in only one way. Now you can see this. This is the two machine. This is the R1, and this is the R2. This is the sample configurations, sample NTP configurations. Here is I am the NTP masters with IP address 10.10.10.1. So it has an IP address, this interface 10.10.10.1, and I will provide all other device with synchronized time sources. So configure device to receive NTP broadcast messages on the interface. Um, so as we see that we have configured a NTP master 1, and then using NTP master 1 command, and now once we do show clock, this is the time stamp. It is showing this is going to be the timestamp for all other uh, router and devices, because they're going to be receiving it from here, from the master. Over here you can see that we are configuring R2 with the NTP server. This is the IP address of this one, 10.10.10.1. So we are configuring R2 with NTP server 10.10.10.1 command. And now if we do a show clocks, we're going to be seeing this. This is the time, and this time was delivered from this routers to here. And now if we do a show NTP status, we can see the clock is synchronized. Stratum is 2, which is 2 hops from the 1 and 2. This is 1 and this is 2. This is 2 hops from the the authoritative server, and this is the reference, which is 10.10.10.1. So this is a good pictures to understand how NTP clock works. Now there is another important feature called NTP authentications. When you set up the NTP, you need to avoid accidental or malicious setting of incorrect timings. The time that a device keeps is very critical. Therefore, the security features of NTP should be used. And there are 2 security mechanisms that are available. The first one is the ACL based restriction schemes, and the second one is encrypted authentication method offered by NTP version 3 or later. You can see in these pictures that NTP authentication, this enables the authentication features. Now NTP versions 3 or higher, it supported cryptographic authentication mechanisms between the NTP peers, and which is client and server. And this authentication mechanism, in addition to access control list, specify which network device are allowed to synchronize with the other network device, and it can be used to help mitigate a network attack. To secure NTP traffic, it is strongly recommended that NTP version 3 or later or higher is implemented. Now we have to use this NTP authentication command in both masters and clients. You can see that defines this NTP authentication key, and then key number, and then MD5 key values. And this command, it defines the authentication keys. And then you see the next one is authenticates the identity of systems to which the network time protocol will synchronize. NTP trusted, and then key number. The key number corresponds to key number in the NTP authentication key command. So when we use NTP authentications, we use the same key number. So that we went to the global configuration mode and NTP authentication key, and then it's MD5, which is a hashing algorithm that I use, and then this is the Cisco 1, 2, 3. And we have to after that we have to use NTP trusted key 1 command. Now if we do the show NTP associations, we can see this is the our masters. Stratum is 2, which is 2 hop away. Um, and then we do this is showing that we need to do both in R1 and R2 NTP authentication. You can see that we have used the show NTP association details command, and it confirms that the server is an authenticated source. This is the authenticated source of the server. This is the usage of show NTP association details command.